this is videoing between one or two of these other things. I should be able to get a good video out of today's class, right? So let's start out today by doing the smiley face program that I got you guys to work on in the lab last week, okay? So, just for a little bit of revision, typically our processing sketches will start with what? What's the first thing we put in our processing sketches? Oh, excellent, great. Void setup. And so, what do we call void setup? What is it in programming terms? It's a method. Okay, so it's a built-in method in the processing framework. When does setup get called? When does it get executed?
At the very start only once, isn't it?
At the very start of your processing sketch, and it only executes once. Okay, so this is code in here that needs to just happen at the start of your sketch to set things up. You would put into this method. So what sort of code do we put into the setup method?
Size.
Yeah, let's put in the size code. So let's put in size 500, 500. So that's going to give us a window which is 500 pixels wide by 500 pixels tall. Yeah. So just out of curiosity, what's this here? The comma. What would happen if you left it out?
It'd be
Would your program run? Would it? No. So things like the commas and the semicolons. Commas what we use to delimit these numbers here. What do we call these numbers? They're arguments or parameters to this method. So they're numbers that we pass into that method to tell it to do something for us. Right. So then we put our semicolon at the end. And then the next bit of code we usually put is the void draw method. And how often does the draw method get called?
Every 60 times.
60 times a second. So it gets called once per frame. So now we want to draw our face, right? So let's just put in the code to draw the face. I want to draw a circle shape. So what do I use to draw a circle shape? Ellipse. So let's say I'm just going to draw my ellipse at 100, 100. And we're going to make this 50 by 50. 50 by 50 in the ellipse there, those last two parameters, what do they indicate?
Height and width.
That's the height and width. So what's the radius of that circle?
Radius is 25.
Oh, 25 will be the radius, because the radius is half the diameter or half the width of the circle. So that's a radius 25, okay? So that's going to give me my face. Now let's put in the eyes, right? So for the two eyes, I want the left eye over to go over a little bit from the center. By the way, the first two parameters for the ellipse, is that the top left-hand corner or the center? That's the center. Okay, so if I wanted this to be, we'll say, over 10 pixels from the center to the left, what would I specify as the x parameter here?
For the left eye?
For the left eye. And I want it to be off to the left of the center. What would I specify for the x coordinate? What? Should it be greater than 100 or less than 100? It's going to be less than 100. We say 10 pixels over is going to make it 90. And then I want the eye to be a little bit up from the center. So should that be greater than 100 or less than 100?
Less than.
So that should be less than as well. Why less than?
Because the
y goes down. Yeah. Did you want to ask a question?
If the radius of the eye is going to be 25, shouldn't it be more than 10 pixels across?
10 pixels is okay. 10 pixels is okay, because you've got 25 pixels this way, 25 pixels this way. So 10 is like halfway along the radius, if you know what I mean.
So won't both the eyes intersect?
What's that?
Aren't the eyes going to end up intersecting since their centers are closer than the radii?
No, because we're going to use 50 as the radius of the face, but we'll use a smaller radius for the eyes. We'll use a radius of 5 for the eyes. That make sense?
Oh, that's the face, okay.
Yeah, so this the first one is the face. Second one is going to be eye number 1, and then we'll have eye number 2. So the left eye and the right eye. So then let's do the other eye, which is basically the right eye. So the right eye, we can specify 110, and now I've got 2 eyes. Let's do the nose. For the nose, let's also use an ellipse for the nose as well. So the nose is going to be the same center as the center of the face. And let's say now I want to draw the mouth. So the mouth, what am I going to use for the mouth? Line. Okay. So I did this in 3 different parts, right? The first part I drew was the flat part of the mouth. And so let's see, I'm going to make it line up with the center points of the eyes just to make everything kind of symmetrical looking. So I'm going to use 90 for that. And then I want it to be down a bit from the center. So we'll say down 10 pixels from the center. Instead of 100, it will be what? It'll be 1. So down a little bit from the center at 100, down 10 pixels from that will be 110. Excellent. So I've got 110 and 90, and then I can go 110 for the end of it, at the end of the mouth, and also 110 for that. Now, I'd be inclined to actually just run this sketch and make sure that all those parameters, those numbers are kind of okay. Oh, look at that. Whoa.
You put the second eye at 110.
You're right.
Yeah, 30
So this should be 110. Excellent. Great. Well spotted. Okay. So that should be 110, and there's the mouth. Okay, so now we're going to draw the little upturned bits at the side of the mouth. So I'm going to pick, as my starting coordinates, I'm going to pick these two as my starting coordinates. And then we're going to use the end of the line will be 5 pixels. 5 pixels off on the X and 5 pixels off on the Y. So 5 pixels off, let's take these two numbers. Let's make this 85, because I won't want to put it too far. And then this one should be maybe 105. And that should give me the left bit of the upturned mouth like that. Let's run it and see what it looks like. It's beautiful, yeah. It's cool. So what am I doing here? I've changed the wrong one. I've actually changed the, that should be, this one here is which? This is meant to be the nose. That should be 100 and 100, and this should be 110. Cool. So let's do the other bit of the upturned mouth, which is on the other side. So this then, let's see. So we have 110, 110. Let's start off with that. 110, 110. So that's going to give me that, and then I want to go 115 maybe. And for this, I want to go 105. Yeah, that looks about right. Let's try it and see what it looks like. Pretty. So that's pretty face-like. Let's try a couple of small changes to this program. Let's change the background color. How do I change the background? Yeah. Did you want to ask a question?
Yeah, for some reason my face is down in the corner.
Yes, I do your size 500 500 in setup, and that will change the size of your window.
I did that now.
Let's see. Just check your spelling of setup. Okay, so the background color. I want to change the background to be all black. How do I do that? Background 0. Well, where should I put that code? In setup or draw? It actually probably is not going to make any difference in this sketch because I don't have any animation in it. If I wanted to wipe the screen, I would put it into the draw method. If I just wanted to happen once, I would put it up here, background. Let's do background 0. Now, I want the drawing color to be white. In fact, let's change it. I want the drawing color to be, what's that color called? The mix between green and blue. Cyan, or what's the kind of European spelling for it? Or what do we call it over here?
Cyan with a fella.
What's the other word for cyan? Teal.
Turquoise.
Turquoise. How do I make the foreground color turquoise?
So you go
0, 0, like 1.
Yeah, don't worry about the color. What's the method for changing the draw color? Stroke. Okay, stroke. Stroke 0, 2.5, so that's green, and 2.5 is blue. And then my fill color I want to be black, so let's go fill 0. And now I should have my little face drawn in the center of the screen, hopefully. There we go, or, you know, on the screen, and it's drawn using those colors. Excellent. So I presume everybody managed to figure that out in the lab. Is that okay with everybody?
Yeah. The Star Trek thing, the actual Enterprise is the most annoying thing ever. Like the
Yeah.
faces, I found the faces easy, but just
Yeah, the Enterprise took a good like 40 minutes.
Really, much easier to do any of those little things with graph paper. You can actually work it out. Just draw it on graph paper first of all. So did I put the solution up? Maybe not. I don't think I did. I'll put the solution up later today, okay? For the Enterprise and for this one. Okay, but it's time to move on and do the next thing.
back at 0.
So the next thing in processing, or the next thing in programming in general, is we look at this sketch here and we think, this is a great little sketch. It's doing what I wanted to do. What if I wanted to make it so that, number one, the face could move? You know, this is a game. Eventually we want to make things move around the screen by themselves. Or what if I wanted to change the size of the face or change the way things are laid out on the face? You know, first of all, if I wanted to change the size of the face, well, okay, if I wanted to move the face, you can see that how many lines of code would you have to do if I wanted to draw the face at a different position? How many lines of code would I need to change? Pretty much all of them. Okay, so we want a way to say, instead of saying 100 and 100, wouldn't it be nice if there was a way of saying, okay, just pick a number and then do everything relative to these numbers that we pick. Instead of saying 100, 100, I'll say, okay, we're going to use some little box over here, we're going to put 100 into it, and we're going to do everything else relative to that. You know what I mean? And then I can move the face around by changing one line of code, instead of changing 6 or 7 or 8 lines of code. And that leads us on to this concept in programming called a variable. And you can use whatever metaphor you like for variables. Variables are a box. That's one that you see in a lot of books. Variable is a box that you put something in and you take something out from. That's a variable. That's a good enough analogy. But when we're making variables in processing, we need to know 3 things about the variables. Those of you that have done programming before will know this. What are the 3 things you need to know about a variable for you to use it?
Type.
So number 1,
Type.
it's type. Okay, so this is a really important concept in programming. Variables have a type. And in programming, in the C# language, in Java, in processing, there's a certain, there's a limited set of types. And that determines what type of information you can store. What's the second thing you need to know about a variable? It has to be initialized. So we have to put some value into the variable so we can get something out of it. And what's the third thing? We need to give the variable a name. We give it a name. Right? So we call a variable a name. Now, in this little simple example here, it makes sense to call our variables x and y because we're going to use it to control the x and y coordinates where the circle is being drawn. So let's look at how we make variables, right? In this example here, let's make a variable to hold the x and y. Now the first thing we have to ask ourselves is, what type of information is this variable going to store? It's going to be a number, okay? So we need a variable which is capable of storing numbers. It turns out there are 2 different types of variable types that you can use to store numbers. There's a variable type that you can use to store a whole number, and there's a variable type that you can use to store a number with something after the decimal point. Okay? Something that's just a whole number is what's called in programming an integer. And in this example here, because we're talking about pixels on the screen, a whole number is fine. You can use an integer, right? So let's make an integer. To make an integer, you type the word int, and that's the type of the variable. And then you give your variable a name. So we're going to call our variable x. So we go int x. And then you press semicolon like that, okay? And that's the variable initial phase of making a variable, and that is called in programming, it's called declaring a variable. All right. Next thing we might want to do is we might want to assign a value into the variable, and that basically takes a number and stores it into that variable. So there's several ways we can do this. This is the first way, this is the easiest way. You just go x is assigned the value of 100. Now, a quick point of information. When I go x is equal to 100, we don't read that as x is equal to 100 anymore. What we read that is x is assigned the value of 100. And from now on, we'll use the word assignment instead of say equals, because equals actually has a different meaning and you use a different symbol for it in programming to compare 2 things. What we're doing here, I'm going to use my pen for this, I'll try this out. Give me this thing. Screen draw. So what we're doing here, this will either work or not, and we'll try it anyway, is we are taking the value of 100 and copying it into the variable x. So it takes what's on the right hand side and copies it into what's on the left hand side, and that's what the assignment statement means. So at this point then, if I wanted to use that variable in my code, everywhere I had 100, I could replace it with the value of x. So there's 100. I replace it with x, right? We'll do the same thing for y. We've got int x. A little shortcut, there's several little shortcuts you can do. If you want to declare multiple variables of the same type, you can just go comma, x comma y like that. Alright, so that's 2 variables, one called x, one called y. Another way of doing the assignment is to do the assignment as you're declaring the variable. So you can go x equals to 100, you can go declare x comma y, and y is equals to 100 like this. And both of these ways are valid in programming. of declaring a variable and giving it some value. You can do it all in one line or separate it into multiple lines as I've done those two examples there. Is that okay with everybody? So the values for x and y now are both 100. So I can take my x here and I can replace x and y. I can replace 100 and 100 with x and y. And it's just going to retrieve the value of 100 and use those in the place where I have 0 and 0. Okay, next thing I might want to do is I might want to take this value of 90 and I might want to say draw this relative to x. So what's 90 relative to x? It's x minus 10, isn't it? So you can say that. You can go x minus 10, like that. And what that does is it retrieves the value of x, subtracts 10 for it, and it uses it as the parameter into that method. Now, here's a big question here. Does that modify the variable x? Does it change the value that's held in x?
No.
It doesn't. All we're doing here is, the only way you can change the value of x is if you see this assignment thing here, okay? If you don't see this, then all I'm doing is making a temporary value, which is based on the value of x, and I'm using it as a parameter here without actually changing the value of x. So that's going to change it. That's going to use that parameter. And then for this one, we could do y minus 10. Okay, so for this one, it's going to be x. What will this one be?
X plus 10.
X plus 10. And this one then will be y. It was 90, so now it's going to be y minus 10. Okay. This 100 here, this will be just what? X and y. This 90 here will be
X minus 10.
x minus 10. This 110 will be
Y plus 10.
y plus 10. This 90 here then becomes x minus 10. This 110 becomes y plus 10. And then this here is going to become x plus 10. And this will become y plus 10. Okay, great. So I've done a big change to my program. I've basically taken out all those hard-coded coordinates, and I'm now using a variable to control the position that I'm actually drawing this face on. So let's zoom out, run the program, and see what it looks like.
You have one of your mistakes.
What's that?
You have 10 and y together. You left out the comma.
Okay, good. Yeah, so there we go. Remember earlier I said what happens if you forget the comma? Your program won't even compile and run. So there we go. So hopefully if that compiles and runs, yeah, it's the same program. And the advantage with doing things like this is I can change this to be x is equals to 200. Rerun the program like this. Oh, why is it doing that?
You didn't call in the X and the Y for the second part of the line.
X and y will be
So it's this problem here. It's these lines here. I haven't changed these to be x and y here, you know. So it's still using these hard-coded coordinates to draw the second the end of those lines. This should really be x plus 10. This should be y plus 10. This should be x minus 15. This should be y plus 5. This should be x plus 15. And this should be y plus 5. So we're drawing this shape now relative to the x and y coordinates, alright? There we go, there's the face. Awesome. Nice thing now is I can take this value for x and say x is 200, I can say x is 300, rerun it, and now I'm going to get the face drawn at a position of 300. So by making one tiny change to the program, you can change the output of the program. You only have to make one small change. And in fact, a good rule of thumb when you're writing programs is to try and avoid using these numbers as much as possible. Even for these numbers here, like the 50 and so on, you know, really we should declare variables for those. Much better. Because then, you know, I can change the size of my face just by changing the value that's held in one variable. There's another really good reason to use variables in this example, and I'm going to explain it to you now, right? Look at this little program here. Looking at this little program, there is a very important concept here, right? Where you declare your variables in a program is critically important, okay? So looking at this program here, I can see that this variable is declared inside the draw method. Can you see that? So that has a significance for a program. When you declare variables like this inside these open and closed curly brackets, then they're considered to be scoped to this curly bracket thing. What that means is you can't use this variable outside of these curly brackets. Now that's a very important concept, and I think you should take a moment to just write that down. Because that is one of the big
Sorry, Brian, say
things.
that again?
Yeah, it's one of the big things that trips up programmers when they get started. When you declare a variable, it's only visible inside the curly brackets that it's declared in. In other words, you can't use it anywhere else in your program. So I'll just make a note here. X and Y they can only be used inside the draw method. I'll give you an example of what I mean by that. If you take this code, right, and you decide to go here and you go x equals 80, and you try to run your sketch, the processing compiler will tell you that you can't use the variable x because it's only visible inside the draw method. Is that okay with everybody? Yeah.
See the way you wrote int x comma y equals 100, but then below you wrote x equals 300.
Sure.
What's which is, I don't really understand. Did you not declare x as 100 and then x? Did you not assign x as 100 and then assign it again as 300?
No, so the first line here, what I'm doing is declaring x but not assigning a value. I'm declaring y and assigning it the value 100. So x at this point has no value. Just it knows that it's an integer type, but it doesn't have a value.
Oh, okay, I thought you were assigning both of them.
Yeah, no, it just does the assignment to the y values. Okay, it doesn't do the assignment to the x. But this will declare the x. It's a good question, right? And then I'm assigning the value to the x. All right, so I'm just showing you two different ways of doing it.
Could you assign the value of x on the same line like above?
Yeah, exactly.
If you wanted to.
Absolutely. You could go x is equals to 300. In fact, you could even do this. So what will happen there is x takes the value of 400 initially, and then it will execute that next line and change its value to be 300. So it overwrites the old value of x with a new value. Is that okay with everybody? So, like I say, we can only use x in this scope here. We can't actually change where we're holding x, or we can't actually use x outside of this method, the way I have set things up. But, of course, you know, this is really cool if all I want to do is draw one face. But what if I want my face to move? If I want to do things with that face, and I want to change where it's being drawn each frame. If I want to do that, then I need to take this declaration for x, and I need to make these what are called global variables. And I move them here. By the way, if you declare something in here, say I go int y, sorry, I won't go int y, int I, this is now known as a local variable. So it's local to the draw method. That's the term that you would use when you're talking about variables, right? When I declare them out there outside of any methods, these are what are called global variables. And they're called global variables because they're declared outside all of the methods. I can use them anywhere I like. Alright, so I can take my global variables and I can come up here and I could now go x equals 500 or x equals 50, it doesn't really matter. What's going to happen here is the sketch will execute and it will run this code first because this gets executed before even the setup method. And it will assign these values and declare these variables. Then it comes and runs the setup method and it will override the value that I've set up here with the new value for 50. And then down here it actually, x is equals to 300. So it's interesting because this program is kind of a bit illegible. Which value for x is the one that's actually going to get used?
300.
The 300 one. So in other words, it will do these instructions sequentially. It does this first, then it does this first to change its value, then it's going to do this to change its value a third time. So x is going to have 3 different values throughout the running of this program, but when it comes to drawing, it will just use the value of 300.
Does it come back out as 300? Or when it comes back out, does it go to the value before it went to draw?
It's basically whichever was the last one to be executed.
Oh,
And in this example, the last one to be executed will be the draw, so it will hold the value of 300.
If you put if you had a 200 line code and then like void like everything, if you put the int equals x, int x equals 400 at the very bottom,
Yeah.
would it take longer for it to actually process than I think?
So again, it would happen sequentially, right? So it would have whatever value x holds when I'm running this particular instruction. This is the value that it's going to hold. And then once it gets to the end, it will change the value of x here. If it then comes in and reruns the draw method, well, if this code wasn't here, it would use whatever happened to be the last value that's held in the variable. So it's a little machine we're always making here, you know, and the machine is going to just step through line by line, instruction by instruction. Yeah.
What do you mean local to the draw method for the I?
It's a term in computer science, right? And it just means that this variable is scoped to within these curly brackets.
Oh.
That's all it means. You say it's a local variable then, right? It means you can't use it outside the method because it's local to that method. And that means just when you declare it inside those curly brackets, that's what happens, okay? So anyway, we have x equals 300. There we go. The x and y can only be used inside the draw. Ah, well, let's get rid of this code here now. So now x and y are global variables, right? And we're going to just say x is 400, y is 100. Let's change these a little bit. Oh, there's x and y. We'll keep them, okay? But instead of going x equals 50, there's a couple of built-in processing variables you can use here. You can go x equals the width. So the width is the width of the screen. And yeah, I can say x equals width. Okay, so maybe I need to jump forward a little bit. You can go x equals width, and then you have that forward slash symbol there. That forward slash symbol in programming, what does it mean? Divided by. So that will take the width of the screen divided by 2 and assign the value back to x. And then you can go y equals the height of the screen divided by 2. Okay, so that's saying x and y are the center of the screen. Again, looking at the program here, what value for x and y will it use to draw the ellipse? Looking at my little program there, which value is 400 and 100? Yeah, they'll use 250 and 250. And the reason why is because what's going to happen is the sketch runs, it executes this code first. So we'll assign these values to x and y. Then it jumps into the setup method, and then it will assign these new values to x and y, overwriting their old values. So it will use these new ones to store the values. Okay, and then let's zoom out here. Run the sketch again, and we should get a face drawn in the middle of the screen. There we go. So it's exactly in the middle of the screen. Okay. So it turns out there's actually a lot of things you can do with variables. The first thing I wanted to say, next thing I kind of want to say is, like, in addition to ints, right, you also have this data type which is called a float. And just for this little example here, I'm just going to change this to be float. Alright? So what I've done here now is I've changed the type of integers from, the type of x and y from integers to floats. Now floats are very similar to integers, but floats can have something stored after the decimal point. So we'll do a couple of little experiments here and see what happens, right? Say I go int I, and I'm going to go float f. Okay, and let's go f is assigned the value of 10. Now here's the thing, right? In programming, when you're doing assignment to a float value like this, in fact, yeah, I'll explain this first. There's a slight complexity here that's kind of important, right? When I do this assignment to a float value here, what is actually happening in here is this is what's called an integer constant, because that has nothing after the decimal point, so it's going to take this integer value and assign it to be this floating point value. If you wanted to take a floating point number with something after the decimal point, you're going to write it slightly differently. You go 10.9, and then you put the single character f at the end. And what that does is it forces the processing compiler to treat this as a floating point number. From this example here, of course it makes a difference because I now have 10.9 as opposed to 10.0. But you're meant to put this little character f at the end to force it to be a float.
So where would you put it then if it is?
What's that?
Where would you put it then if it is just 10? Like if you go
Just 10f is fine. You can go equals 10f. Or if you want to be really pedantic, and you see a lot of programmers write like this, 10.0f. Okay, that again forces it to be a floating point number. If you're just using the value 10, it doesn't make a wild bit of difference. But watch this, right? There's the value of 10.999, and there's the value of I. If I go I equals f, so now what I'm doing is I'm taking a value with something after the decimal point, and I'm assigning it to be something with nothing after the decimal point. So we have a couple of interesting things here, and lots of possible outcomes for this. Interesting question though. What is going to be the value of I after I execute those instructions? So will it have the value of 11, will it have the value of 10, or will it not compile? So there's three possibilities. Okay, let's take a vote. How many people think it won't compile? How many people think the value is going to be 11? How many people think the value is going to be 10? Nobody thinks the value is going to be 10. That's really interesting. Okay, let's run the program. Right click stop on the sketch and click play. Okay, so the answer is, and the correct answer is, that it won't work. And the reason why it won't work, if you're writing this in other languages like the C language or C++, not C#, but this code would just work. It would just do the conversion, right? But this is processing based on Java, so therefore, what it's basically saying is, here, look, you've got this number 10.99, and you're trying to assign it to a variable which can't hold the 0.999. Are you sure you want to do it? Can't convert from float to int. Okay, so your program is telling you you can't do that conversion. So the alternative, if you actually want to do that, what you have to do is put what's called a cast. And to do a cast in programming, all you do is open bracket, the type that you're casting to, and then close bracket. And what that will do is it will convert this to an integer, and the next question then is, what's the value going to be in I after I do the conversion successfully? Is it going to be 10? Is it going to be 11? So this is now going to work, right? But let's print the value out. I don't know if I mentioned this, but you can print stuff by going print ln I. Now without running it, what do you think the value that's going to get printed out is going to be? Is it going to print 10 or is it going to print 11? Let's take a vote. How many people think 10? How many people think 11? Wow, you're right, the rest of you are wrong. The answer is 10. And the reason why is because the program just doesn't bother doing rounding or anything like that. All it does is what's called truncate. So it gets rid of everything after the decimal point. Wouldn't it be really interesting if I ran this program and actually printed out 11? I'd be so embarrassed. Save my blushes program, work. Woo! Prints out 10, you can see it there. When you do print ln, it gets printed here to this console thing. Okay, so that's integers and floats and casting. Okay, I'll put a big example of all of this stuff up. It's time to start doing things with our numbers, right? Let me get rid of this little bit of code here. If you want, you can take it down and notate it yourselves, right? But what I now want to do is I am now drawing my circle at a particular position. What I want to do is I want to modify my program so that instead of always drawing the face at the same position, well, let's just put a bit of code in here and see what happens, okay? I'm going to put some code in here. X equals X plus 1. So one line of code we've changed. Let's then go and run this program. Actually, before I run the program, what do you think that's going to do? Yeah.
Move everything one to the right.
Yes, what's going to happen here is before we even run this program, we can think about what's going to happen. I've given X the initial value of, never mind 400, width divided by 2 and height divided by 2. So its initial value is the center of the screen, right? I then come in and I run this draw method and I draw the circle. The last line of this circle is this line here. The last line of this method is this line. So what's this line do? It says X takes the value of, because that's what equals means, the value of X plus 1. So this has the effect of taking the old value for X, adding 1 to it, and assigning it back to X. That's what happens here, okay? Maybe I'll just write a little note on that. Other, let me use that. Yeah, okay, so I'm just put a note on this.
Take the old.
You know what? I'll put a comment on this then.
It's a little bit.
So that takes the old value of 1, adds it back, and then assigns it back, right? And just, let's do PRINTLN and print the value for X there, so we can see it. Alright, this is exciting. Is everybody ready? Let's click play, and let's make our first thing do something on the screen by itself. Oh my goodness, look at
Is there
that.
independent face?
It's gonna happen.
Huh?
Is there independent face?
Yes.
Things on his own.
Kind of. It kind of is, but it leaves a streak. It's like a snail. It's leaving a trail. How do we fix that? Yeah, let's wipe the screen each frame, and then it will not do that. There we go. Now we get the circle moving by itself from one side of the screen to the other. Are you impressed?
Yeah.
Okay, it's not quite Call of Duty yet, right? But we're getting there. You can hopefully see here the value for X is constantly changing. It's increasing by 1 every time we print it out. The face has now gone off the side of the screen. The X value is like 1,500, so it's still increasing the value for X. We're just drawing it well off the side of the screen there, you know? Okay, so I want to show you some more things you can do with variables, right? So there's X equals X plus 1. That means take the old value of X, assign the new, add 1 to it and then assign it back again. We can do that in various different ways. You can go X plus plus. This means the same thing. Okay? You can also do plus plus X. Now these have a very subtle difference, which I'm not going to go into today because I don't want to confuse you. But essentially, this will also do the same thing. Okay? We'll do the difference between those another day. There is a very subtle difference. Okay, all of those will increment X. In other words, they'll add 1 to the value of X. There's a couple of other ways you could write that. You can also go X plus equals to 1. And then of course, because you can go X plus equals to 1, you can go X plus equals to 5 or whatever. So if you don't just want to add 1 to something, you want to add 7 to it. What this statement means here is take the old value of X and add 7 to it. Alright? So that means take the old value of X and add 7 to it. Okay, so there's plus plus and then plus equals to, yeah, that's all of them. So when you can do plus, you can also do minus. You can also go things like this, X minus equals to 7, and that will subtract 7 from the old value of X. So this is how you subtract numbers from variables. You can also do things like X multiplied by equals to 7. And what that's going to do is going to multiply X by 7. So if X is the value of 10 and I did X multiplied by equals to 7, its new value would be 70. So it takes the value of X, multiplies it by 7, and so on. And then of course you can also do X equals X multiplied by 7, which means the same thing. And of course you can do stuff like X equals Y multiplied by Z. So anywhere you have a variable, you can replace it. Anywhere you have a constant, you can replace it with a variable, So this is take the value of Y, multiply it by Z, and assign it back to X. So there are things you can do with variables, okay? So, as a little exercise, just for some practice with variables, will you modify this sketch a little bit so that instead of getting the face to go from left to right, can you get the face to start in the top left-hand corner of the screen and go diagonally down to the bottom, start in the top right-hand corner of the screen and move down to the bottom left-hand corner of the screen? You follow what we have to do?
Yes.
So I want it to start up here and move all the way down to there. So declare whatever variables you need to do that, and take 5 minutes to see if you can figure out that code, okay? Interesting thing. We're going to resume there, okay? So, here's my little sketch. What I'm going to do here is delete some of this code that I previously have. I'll delete this stuff here. And I'm going to put a big sketch up which has all of operations, they're called, things you can do with variables. I'll put a sketch on. So let's go x plus equals to speed and y plus equals to speed. So I'm always adding something to the x and y. In fact, let's call this x speed and y speed, just in case I don't necessarily want them to go always in the same direction. So then up here I can go float x speed, comma y speed, and then up here I can go x speed. In fact, it doesn't really matter, I can just do them here. I can go x speed equals -1 and y speed equals -1, and then of course I would need to specify the starting position. So instead of being width, it should be probably something like width -25, and instead of being height, that should be 25. Why 25? Yeah, because the radius of the circle is 25. So if I want the circle to be always on the screen, then I don't want to start it at 0, 0, because that's going to be, half the circle is going to get drawn off of the screen. So now it'll get drawn on the screen. Probably a better thing to do would be to declare another variable here called radius of circle, or circle radius. Let's do that. And then use that, much better.
Would y speed not be 1, not -1?
Yeah, y speed should be 1, you're right, yeah. Well done. And let's do another variable here, float radius. And we'll say radius is 25. So y is going to be equals to the radius, and this is going to be equals to the radius. And then down here, instead of using 50 and 50, I want to say twice the radius. How would I say twice the radius?
Radius.
Yeah, just radius multiplied by 2. I want to be really good about it. I should really write radius multiplied by 2.0f. Okay?
Is the 2.0f just to satisfy a code, that's it?
Not really. There's good reasons why you want to do that. Occasionally, in this example, it might not make too much difference, right? But occasionally, if you multiply an integer by a float, depending on what way you've written your code, what it will do is it will do the calculation in integer form. So if you have something like 2.5 multiplied by 2, you may end up getting 4 instead of 5. So if you want them to explicitly always use floating point numbers, then use floats. You use these what are called float constants, and that forces the calculation to be in float format rather than in int format. So yeah, that should probably work. Okay. Yeah, wonderful. And then the nice thing about having variables to do this is I can change my x speed to be 2, in which case it will move from left to right twice as fast as it moves from top to bottom, and it will go off the side of the screen. Okay. Next thing we want to do, okay, is we want to be able to make our programs make decisions. So we can do things in a sequence like this, right? But what we really want is we want our... Did I start that thing? Yes, it looks like it started. And this other thing is started. Yes, okay. So we want our programs to be able to make decisions, right? In order to make decisions in computer programs, we have to use another statement, and that statement is called the if statement. So the if statement looks like this, right? You go if, open bracket, and then you have something in here which is going to evaluate to either the values of true or false. So you can go if x is equals to 500. Okay? And then you go open bracket, close bracket like that, curly bracket. You put it on a separate line. This is how we make our programs slightly more interesting in that they can make decisions, alright? So, the first way of comparing things is using this. And this is the comparison to check to see if things are exactly the same. So again, a common mistake that people make is they put a single equal symbol in here. If you put a single equal symbol in here, what will happen? In some languages it would. In C it would. In actual Java and processing and C# your program won't compile. So 2 equals means compare two things and check the value, alright? 2 equals like that means compare two things. So if x happens to eventually end up with exactly the value of 500, it will do something in here. And let's do something. Let's go. (255, 0, 0). So if x takes the value of 500, let's not do 500. Let's say if x takes the value of 250, we'll say. And then my x speed and y speed, just to make sure that it will definitely hit that value, let's make these 1. And what's going to happen now is as soon as my sketch runs, as soon as the X value reaches the value of 250, it's going to change the fill color. Alright, so let's run the sketch and see does that happen. So there we go. As soon as X takes the value of 250, it changes the fill color. Does everybody see how that works? So that's what the if statement looks like, right? So just to be clear again, it's if, and then open open round brackets. You have this bit of code in here which must evaluate to either true or false. And then you've got open curly bracket on the next line, close curly bracket. And if this evaluates to true at some stage in your program, it will execute this line here. If this never evaluates to true, this code will never happen. Okay? We can also check things like greater than or equal to. So this is greater than. This is the less than symbol. You can do greater than or equal to by using that symbol. You should write these down, yeah? Because you forget them. They're in the processing book as well, just so you know what all the symbols mean, okay? This means if X is a value which is greater than or equals to 250. This is less than or equals to. This here means not equals to, okay? This first symbol here, do you know what it's called? No. In programming, what do we call that term?
Not equal.
Yeah, it's called not equals to, but even this particular symbol, well, we would call it an exclamation mark. It's called a, say again? No, but good guess. It's called a, you like it. It's called a bang symbol. It means, it doesn't mean anything. It just means, you know, in programming, in these languages, it means not. So that's not equals to. So if X is not equals to 250, you do something there. Cool. There's a couple of other ones you can do as well. You can say something like, if X is less than 250, sometimes I want to combine things. I want to say if X is less than 250 and Y is, so the Y is going positive. So if the Y is greater than 100, so this symbol here, when you see these two ampersand symbols together, two of them together mean and it means that both of these conditions must evaluate to true for the whole thing to evaluate to true. So everything here must be true, otherwise the thing is false. Right? So this has to be true and this has to be true, in which case it will do this bit of code here. If one of these is true and one of them is false, will it do this bit of code? No, only if they're both true. And then the other thing we can do is this symbol here, which is called, I'll tell you in a minute, symbol. And that's the OR symbol. And that symbol, does anybody know what the symbol is called? The actual symbol. The two vertical, the two, or the what you call it, the vertical line symbol like that, does anybody know what it's called? It's called the pipe symbol. So two pipes means OR. Yeah. What's that? It's different on different keyboards, yeah? I'll come down and have a look and I'm sure we'll figure it out. Okay, it's time for you to write your first bit of game AI. Okay, our first bit of game AI, right? Because now we have enough to be able to declare variables, to add variables, subtract them, multiply them. We know how to draw things. We know how to make our programs make decisions and do different things. It's time to write a program, okay? What I want you to do is have the little smiley face start where it starts on the screen, move across the screen, and as soon as it gets to the right hand side of the screen, what do I want it to do? I want it to come back again. And as soon as it gets to the right hand side of the screen and comes all the way off to the left, what's it got to do? Change direction. So it just needs to oscillate back and forth across the screen. See if you can figure it out, and don't worry if you can't figure it out, okay?